security scanner for AI agent skills, detect vulnerabilities, malicious patterns, and security risks before installing agent skills. AI agent skills used by Claude Code, Codex CLI, Gemini CLI, and others run with implicit trust and minimal vetting. Research shows over a quarter of skills contain vulnerabilities and a small percentage show likely malicious intent. SkillSpector helps answer the question, is this skill safe to install? The tool offers a development guide that explains its architecture, package layout, and how to extend the analyzer pipeline. Key features include multi-format input, scan Git repositories, URLs, zip files, directories, or single files. 64 vulnerability patterns across 16 categories such as prompt injection, data exfiltration, privilege escalation, supply chain risk, excessive agency, output handling, system prompt leakage, memory poisoning, tool misuse, rogue agent, trigger abuse, dangerous code, taint tracking, Yara signatures, least privilege, and tool poisoning. Two-stage analysis. A fast static analysis followed by an optional large language model semantic evaluation. Live vulnerability lookups that query a public database for known CVEs and fall back to an offline list if the network is unavailable. Multiple output formats, including terminal, JSON, Markdown, and Serif reports. A risk score between 0 and 100, with severity labels and clear recommendations. To get started, clone the repository, create a virtual environment, and run the supplied installation targets. You can install for production or for development with optional dependencies. Use the command SkillSpector scan with a local directory, a zip file, a single skill file, or a public repository URL. Specify output formats with a flag, format and optionally output to a file with output. LLM semantic analysis can be enabled by configuring an OpenAI-compatible endpoint. A provider variable determines which service to use. An optional environment variable supply the needed credentials. If you prefer to skip the LLM step for speed, use the No LLM flag. The scanner recognizes ADA for patterns grouped into categories. For example, prompt injection includes instruction override, hidden instructions, exfiltration commands, behavior manipulation, and harmful content. Data exfiltration covers external transmission, environment variable harvesting, file system enumeration, and context leakage. Privilege escalation checks for excessive permissions, sudo or root execution, and credential access. Supply chain risks include unpinned dependencies, external script fetching, obfuscated code, known vulnerable dependencies, abandoned packages, and type squitting. Excessive agency looks for unrestricted tool access, autonomous decision-making, scope creep, and unbounded resource use. Output handling issues involve unvalidated output injection, cross-context output, and unbounded output size. System prompt leakage seeks direct exposure, indirect extraction, and tool-based exfiltration. Memory poisoning covers persistent injections, context window stuffing, and memory manipulation. Tool misuse examines parameter abuse, chaining abuse, and unsafe defaults. Rogue agent patterns look for self-modification and session persistence. Trigger abuse covers broad triggers, shadow command triggers, and keyword baiting. Behavioral AST detection focuses on dangerous function calls such as exec, eval, dynamic imports, subprocess calls, system calls, compile, dynamic JEDitor, and chained execution. Taint tracking monitors data flow from sources to sinks, with high-severity credential exfiltration chains. Yara signatures flag malware, web shells, cryptominers, and exploit code. Least privilege checks look for underdeclared capabilities, wildcard permissions, missing declarations, and overdeclared permissions. Tool poisoning detects hidden instructions, Unicode deception, parameter description injection, and mismatch between declared and actual behavior. The risk scoring system assigns points based on severity. Critical issues add 50 points, high issues add 25, medium 10, low 5, and executable scripts get a multiplier. Scores are mapped to severity levels. 020 is low and safe, 2150 is medium and cautious, 5180 is high and advises against installation, 81100 is critical and advises never to install. A typical terminal report shows the skill name, source location, scan time, risk assessment metrics, the number of components and their types, and the most serious findings with location, confidence, and explanation. The report also lists the files scanned, whether they are executable, and provides actionable advice. Configuration is handled through environment variables such as the provider, API keys, model overrides, registry overrides, and log level. Command line options let you choose the output format, specify an output file, skip LLM analysis, or increase verbosity. Under the hood, SkillSpector operates in 2 stages. Stage 1 performs static analysis using regex patterns, abstract syntax tree checks for dangerous calls, and performs live vulnerability lookups against a public database. Stage 2, if enabled, uses a large ML to evaluate context and intent, filter false positives, and provide human-readable explanations, boosting precision. Live vulnerability lookups fetch dependency data from a public API, require no keys, batch queries, autofallback if offline, and cache results for an hour. The tool needs outbound HTTPS to that API, but if unavailable it falls back to a small static list. Limitations include possible gaps for non-English content, inability to analyze images, binary code, or runtime behavior, and reduced functionality when offline. Research underpinning the tool analyzed over 42,000 skills, finding about a quarter vulnerable and a small percentage with likely malicious intent, with executable scripts further increasing risk. If you want to use SkillSpector programmatically, import its graph module, invoke the analysis with a path, desired output format, and a flag to enable LLM, then read the returned risk score, severity, recommendation, and filtered findings. The code is released under the Apache License 2.0. Contributions are welcomed, and issues can be reported on the project's GitHub repository.